Hi everyone. In today's video, we are going to discuss this example. Actually, this differential equation is of reducible to exact differential equation type. So with the help of this example, we will see how to solve such types of examples, which are the methods of finding the solution of this problem, right? So let us start with a basic concept of exact differential equation. We will revise the concept first and then we will start to discuss this example. So when we say the differential equation is exact, so when you have differential equation of this type, m dx plus n dy is equal to 0. Here m and n, these are functions of x and y, getting like this. Dx, you have some function of x and y, dy having some function of x and y. When we say it is exact, if partial derivative of m with respect to y is same as partial derivative of n with respect to x. If these two partial derivatives are equal, we say it is exact, and there is very simple method to solve such problems. But see, if it is non-exact, no need to worry. With the help of integrating factor, we can convert it into exact and we can solve. So let us start with this example, given example. Let us write the m first. So here m means multiple of dx. As you can see here, this is our m. What is our m? Y, xy plus e raised to x. You can see there is a product of this bracket with y. So my suggestion to solve the bracket and make them separate, it is quite easy to differentiate and integrate then. So I'm multiplying, so xy square and this y e raised to x. This is our m. N is multiple of dy. Actually, in standard format, we have a plus sign, but we got a minus sign. So we should consider that sign here, minus e raised to x. So let us check these two partial derivatives are equal or not. So now, derivative of m with respect to what? With respect to what? Y. How many terms are there? 2. What is sign? Addition. I can take separate derivatives. Derivative of this x y square plus derivative of this y e raised to x. After that, generally constants, we take them outside, so the problem or the differentiation will be more simple. We are differentiating with respect to y, so that x is constant will come outside. Here e raised to x is constant since we are differentiating with respect to y, right? So let us find derivative of y square. So here the standard formula I'm going to use. So derivative of x raised to n, when you have function like this, derivative is n x raised to n minus 1. That means whatever the power we should write first, we reduce the power by 1. So let us do. This is x power 2. I'm writing it here. I'm reducing the power by 1. So y raised to 1. E raised to x. Derivative of y with respect to y is 1 obviously. So 2xy e raised to x into 1 e raised to x. So I got the partial derivative dy by m by dy by y. Let us move further. Let us find the second partial derivative dy by n by dy by x. Where shall I write here? N. Only one term is there. So minus sign is constant. We can take outside. E raised to x. Getting? So derivative of e raised to x. E raised to x. Okay. So now both of them should be same. Then we say it is exact. But see here we are getting both of them are different. So that means the given differential equation is non-exact. So let me mention. Just a minute. Dy by n by what? Dy by y not equal to dy by n by dy by x. It means given differential equation is non-exact. Equation is non-exact. But see, no need to worry. We can convert it into exact. How to convert it? There are 4 different rules of finding integrating factor, and that integrating factor will convert this differential equation into exact. Let me write those 4 rules. Okay, those 4 rules. So maybe my viewers who are watching my videos regularly, so maybe they will think in each and every video I am revising all those 4 rules. Getting? So reason is also there. If you revise all those rules again and again, so you can easily recall at the time of examination also. So you should prepare those 4 rules properly, then you can easily solve problems like this. Okay, so in this video also I will revise those 4 rules. The first rule is dabba m by dabba y minus dabba n by dabba x upon n should be the function of y, then integrating factor is e raised to integration f of y dy. Sorry, here I should have x, getting na, e raised to f of x dx. So you see, when you find this value, its value, it should be the function of x only. There should not be y. Then this will be the integrating factor. Second rule, dabba n by dabba x minus dabba m by dabba y. This time m is in denominator. So it should be the function of y only. Then integrating factor e raised to integration f of y dy. Simply I interchange them here. Denominator n replaced by m. Here we should get a function of y. Here we should get function of x. So these are the first 2 rules. Third rule, the differential equation should be in this format. Should be in this format. Okay, you can see y f1 of xy, function of xy dx plus x, f2 of xy, function of xy should appear everywhere, right? So if it is in this format, then third rule is applicable. I'm not writing third rule right now. The fourth rule is applicable if the given differential equation is homogeneous. Power of each term must be same. So generally, when we have to check which rule is applicable, we will start with the fourth rule, since it is quite easy to check. Homogeneous power. See, you combine power x1, y2, combined power is 3. But see, here you cannot find power. Here also you cannot find power. So definitely the fourth rule is not applicable. In third rule, xy should appear everywhere. Here we have just x only. There is no any y in neighbor of x. Getting? So the third rule is also not applicable. So just we have 2 options. Either the first rule is applicable or the second. Without solving, you cannot decide, you cannot find which rule is applicable. So what will I do? I will start with rule number 2. We will check whether it is applicable or not. We will check whether we are getting function of y or not. If it works, then we will move further in that way. If it doesn't work, then I should go for rule number 1. Okay, so let us start with rule number 2 here. So consider, so the rule number 2 says dabba n by dabba x minus dabba m by dabba y, right, upon m. What is dabba n by dabba x? Where is it? Minus e raised to x. Dabba m by dabba y here. Okay, minus sign outside, so sign will get changed. Minus 2xy minus e raised to x m. Where is my m? Here is my m. Okay, so see why we have taken m, no? Yes, y we have taken already outside, so y xy plus e raised to x. So actually we expect just function of y only, but see many terms are there. So let us try to simplify. Let us see, can we add, can we subtract, can we cancel anything? Minus e raised to x minus e raised to x, you will get minus 2 e raised to x minus 2xy upon y xy plus e raised to x. Still terms of x are there. Tell me, can we take common anything from numerator? Minus 2 we can take common only, right? So we have e raised to x here plus minus sign outside, 2 outside, just xy is there. In denominator y, xy plus e raised to x same as e raised to x plus xy. See, both terms are same, the brackets are same, so we can cancel out. And just remaining part is minus 2 by y, right? So yes, we expect the function of y only and we are getting same. So this is f of y. It means rule number 4 works, sorry, rule number 2 works here, getting? So I will go further in that way. The integrating factor will be e raised to integration f of y dy. Let me remove this part. So let us find integrating factor now. Just a minute. Here I will write integrating factor is e raised to integration f of y dy. So e raised to f of y, this minus 2 by y. Tell me how to integrate this one. Generally the constants we take outside, So e raised to minus 2 will come outside, 1 by y dy. What is the integration of 1 by y? It's log y. Okay. So e is there, log is there. So most probably they will get cancelled, but we cannot cancel because minus 2 is there. But no need to worry. We have this property of log n log a. So if you have n log a, you can write log a raised to n. Whatever the multiple of log, you can write as the power of a. That rule is applicable here. E raised to minus 2, we can write as a power of this y. So y raised to minus 2, e log will get cancelled. Y raised to minus 2, that means 1 by y square. If you shift the term at denominator, that sign of power will get changed. I got this one, right? So this is integrating factor. Yes, finally we got it. So it has that magic to convert the given differential equation from non-exact to exact. So let us multiply given differential equation by this 1 by y square. Okay. So multiplying given differential equation by 1 by y square. Okay. So let us see. 1 by y square here, no? Yeah. See, there are two terms. So I'm dividing each term by this y square since it appears in denominator. So y xy plus e raised to x y square. It is in denominator, no? So that's why it will appear here also denominator. Minus e raised to x upon y square dy is equal to 0. Can we cancel anything? Yes. Y will get cancelled. Xy plus e raised to x upon y dx minus e raised to x upon y square dy is equal to 0. Divide separately. Xy upon y will get cancelled. X plus e raised to x upon y dx minus e raised to x upon y square dy. So this is an exact differential equation. Okay, no need to verify it again, no need to check whether it is exact or not. Yes, it is exact definitely. Since initially it was non-exact, we multiplied by integrating factor. That means definitely now it is converted into exact. So we should note down what is our new m, new n. So that was old mn, this is new m, this is new n. Getting? So yes, we got it. So after that we will move towards the solution, but before that I will write m and n. Just make a screenshot of it, then we will move further. See, I have written that m and n, new m and new n. Okay, so we got the exact differential equation, so I got m and n. So now let us find the solution. Okay, so the solution of exact differential equation is fixed. It is integration m treating y constant with respect to x, integration n free from x with respect to y is equal to c. So the solution is fixed, which is the addition of these two integrals. What will I do? I will solve the first integral first, then I will go for the second integral. Consider integration m treating y constant with respect to x. Okay, what is my m? This is my m. X plus e raised to x by y dx. Addition is there. I will take separate integration. Integration x dx plus integration e raised to x by y dx. As we mentioned, constant outside. So if there are any constants, we take them outside. Here is no any y. Here 1 by y, which is a constant. I can take it outside. Let us find its integration first. The integration formula of integration is x raised to n is x raised to n plus 1 upon n plus 1. Formula is quite simple. Whatever the power, we increase it by 1 and the same number in denominator. Power is not there, that means power is 1. Apply that formula. 1 plus 1, 2. Same number in denominator, 2. 1 by y is a constant outside. You have just e raised to x. Will you tell me what is integration of e raised to x? It's very famous formula, right? E raised to integration of e raised to x is e raised to x. So 1 by y into e raised to x. That's it. So this is the value of the first integral. Let us move further. Second integral, right? Now what we have written there? Integration terms in n free from x dy. That means we are finding terms of n in which x is not there. Here x is there, so you cannot that term getting, so only one term is there which has x. That means you cannot take that term. It means the value of this integration is 0. And the formula says the solution is nothing but the addition of these two integrals. Okay, so simply we need to add. Solution is, let us add x square by 2 plus 1 by y into e raised to x by y. If you add 0, you will get same. So let us ignore is equal to c. So this is required solution. Ready? So finally we got the solution of this problem, right? So see, I hope you understood, okay, how to solve when you have any a differential equation which is non-exact, right? So I'm giving one more problem for you. You can try that problem on your own, and in case if you have any difficulty, you will get the solution of that problem in my next video. Just make a screenshot of it, then I will give the next problem. So this is homework problem for you, okay, I will mention here. So you can try to solve on your own, getting, and in case of difficulty, watch my next video. We'll stop here. Thank you. See you in next video.